this part of the input looks pretty similar, but does this part of the input actually act differently? That is, are any differences, even if they're pretty small, right, meaningful? Because there were differences. Our JS divergence wasn't 0, right? But they're small. But are they meaningful? They might be, because small differences in the input distribution could snowball into learning outcome differences. And so, for example, if we look at WH dependencies across these two input samples, you can see that the most frequent WH dependency is a matrix clause object, like what did Lily read, start IPVPN. It makes up about 3/4 of the WH dependency input, but it's, slightly more frequent in our low SES sample. And the next most frequent one is a matrix clause subject dependency, like what happened, so start IP end, and that's a little bit more frequent in the high SCS input sample, but overall these make up like 80-some, almost 90% of the input, right? And if we look at the syntactic trigrams, the building blocks of our matrix clause object basically make up like 80-some% of the input. Again, small differences across SCS. The next most frequent syntactic trigram is the building block for our matrix clause subject, start IP end. It's a little bit more frequent in the high SES. And then, of course, there are other syntactic trigrams that are much less frequent. There are small differences, right? But do they lead to learning outcome differences? And this is where we can use developmental computational modeling to find out. So we use judgments from a model child learning from the same amount of data as low SES children seem to, with those data having the same composition as our low SES child-directed speech data. And then we plot all of those 4 island type stimuli on these interaction plots. Again, we're going to have the length of the dependency as one factor, matrix versus embedded, and the absence or presence of an island structure as our other factor. And on the y-axis is going to be our probability in this case instead of z-score acceptability judgment rating. We're looking for that additional unacceptability for the island crossing dependency above and beyond the fact that there's an island structure, above and beyond the fact that we have an embedded dependency, super additivity. This is our sign that syntactic island knowledge for that syntactic island has been acquired. And lo and behold, this is what we see. Hurrah, right? All 4 islands have this super additivity, that additional unacceptability that we're looking for as a behavioral signal, as a measurable outcome for syntactic island knowledge. So this means that low SES input is predicted to support the same learning outcome knowledge of these 4 syntactic islands.